website. So I'm going to my classroom website, and then inside the classroom website, you will find out 384. Okay, but let me go sign in here. Yeah, so in my classroom, I have 383, so 384. So I'm going to the second one, decision making. Okay, so please change this one. When you submit your lab report, please change this one to spring 2021. Okay, so please change this one. We'll follow this document. This document is telling us to program selection statement. So when you go for this laboratory, this taxes, if you're going to go, so there are several taxes. We have around five taxes. Okay, so if you go to these taxes, that times you will find out that you need to manipulate with selection statements. Okay, selection statements. So you are going to learn how to program with selection statements and how to apply the selection statements in various varieties of problem domain. Okay, or problem example. Okay, then also you are going to learn about condition and logical operators to control the selection statements, how you manipulate the selection statements. You're going to learn this. And to implement loops for a variety of examples, you're going to learn that how to implement the loop. Okay, so these three are
class usually.
After this class, you are going to learn about these three things. That's for confirm. Maybe the loop, we are not focusing too much in that, but loop is the mandatory things, right? You have to learn those things. You already know. But these two, you will already learn the three things you will learn after this lab. I believe so. So the task one is telling that a student is asked to develop a program. So you are being asked to develop a program that will take an integer input. So he will take an integer input. So you can give any integer input within 1 to 100. Obviously, that should be 1 to 100. Okay, and print the corresponding grade. So your grade should be printed. Like if the number is greater than, so what is the hints of the program? That number is greater than equal 90, so you will print A. Number is greater than equal 80, you will print B. Number greater than equal 70, you will print C. And number greater than 60, you will print D. And number less than 60, you will print F. Now, when the students has been asked, so they are going to write this program, but the students has been asked to use switch statements, and he made the mistake. So here in this here, he used switch statement and he made the mistakes. So you have to find out where the mistakes he has done. So you will have the program called grade1.java with the following questions. Okay, so what you need to do, you have to go through the program. Okay, so what is my program file? Okay, so this is my program. So let's see, I have a grade 1 program here. So this is my grade 1 program. You can download this one, and I have written here. So I want to write for you guys as well, because you are the new, still new. So I don't want to give you the code and just explain the code so that you can understand. Let's go for implementation as well, because you are going to implement with me as well, right? So file, new file, and we are going to have an empty Java file. I'm writing this one as a lab 1. So you are grade, let's see, you are section C. So C grade 1 dot Java. So this is the programs I'm gonna write. Okay. Now in this program, first things I can also copy and I can show you that. First things here, we're gonna do that. I want to create a class. I have to create a class. So when I'm going to create this class, that times I have to mentally think that the class name should be this one, because I want to put inside this one, I want to put my my main program, okay, main function. Okay, so that's why I write here. Let's see, I'm writing here public class grade 1, grade C1. So this one is my class. So driver class, where I have a function called public static void main. So this is my main functions, and inside to string argument. So string, then array, then yes. Compulsory programs. That's always I need to do. Have done this one. Now they told me that take an input from the console. So I have to take an input. So I'm using a scanner class in equal new scanner. Then inside here, I have to write system.in that we have learned in our previous class, right? Last class. And then we have to do like, we have to take a variable. Let's see, integer number. We have taken number equal in dot next integer, right? So these are functions that we're gonna call. Now this function is not showing as blue because I don't have taken this class. So I need to take this class as an input. So import, I'm using a scanner class which is inside. I'm using a scanner class which is inside java.util package. So that's my scanner class. So I'm taking this one and in dot next integer I have taken. So this one is now number I have taken. Now I have to check that these numbers, so I have to use switch statement to represent corresponding grade from this number, right? So I'm using switch. We know that is WIT switch, and switch statement always take a word. Always he doesn't. You cannot compare here anything, okay? In the switch or case, in the case or switch, as I have mentioned that greater than equal, so you cannot write down greater than equal. Okay, what we can do, we can write like if switch, I can take the number, I can pass the number in the switch, and then case will make equivalent. So automatically the equivalent they will check. You don't need to compare anything in here. So the number you are passing here, not the evaluation, not the expressions you are passing here. You cannot pass any expressions in here, number into true. You cannot do that, okay? So you cannot do that. It will be a problem. Let's see. Let's see. So actually what is happening, although you are passing an expressions, but expressions is evaluating a value, so that value you will compare. So here we are passing number as a variable, so we are passing a token which hold the value, which has a value. So that type of token we are passing. Let's see, I can pass here the final integer, let's see 20. So I can pass the number as well, no problem in here, because this one is a literal as well. This one is a literal, and this constant token has a value. So if he has a value, you are passing this value. That value can be evaluated and expressions and generate the value as well, no problem. So one value, it will hold one value. When you are considering this one, the value can be character, the value can be numerical, the value can be constants, the value can be characters type, the value can be string, whatever this one. So you want to match this. So you are using case. So you want to match this by using case. So let's see, I'm using, the number is 90. So when the number is 90, I want to print that system.out.println, system.out.println, and yeah, so system.out.println, system.out.println. I am crossing break, okay? Now this one is the if case 90, if case 80. So automatically the match will happen. So wherever it will get the match, you will flow on this one. You will go to this block. Basically this one is a block, okay? So okay, so we are using here. So let's see, we are using case. So we are using this one. So let's see 90, and then we are using 80, then we are using 70, then we are using 60, then we are using here, let's see, default. So default should be smaller. Every keyword is smaller. default. Now, for the switch statement, we know that if anyone will be true, it will go to the block. So it doesn't need to true for others. It will continue to go to the end. Okay. So to break down the connections, we have to use break, right? You have to use break. So break means that you have to stop in here. You cannot proceed. You have to stop it. Okay, I will remove. I will show you that what will happen. Okay, so let's see. I have B here. I have C here. I have D here. And I have F here. So what does it mean? That if case 90 number is 90, it will go to A. Number 80, it will go to B. Number 70, it will go to C. Number 60, it will go to D, and then default F. Now, when we run this one, we have seen that, what is this? What is the problem? Yeah, so number, integer. Oh, so sorry, I have changed that. I didn't.
Sir, here 20, sir.
No, it should not be. It should not be because I'm going to scan. Yeah, so number should be, that's I want to show you that constant we can use. So number, when number will come, so that times we have, now we are building this one. So the number you are going to take. So that's the number we are going to take, right? So let's see, the number is number. What is the value of the numbers we're going to input? So let's say I'm giving 80. I'm giving 70. I'm giving 50. What will happen? 56. Then enter. So it will go to F because default one, it doesn't match to anyone. By default, it is going to F. Okay. So if I will give, if I will give 890, what will happen? Yeah, so the point is that A, B, C, D, E, F. So remember, in the switch statement, in the case statement, if any case statement will be the expressions, here you will be the expressions. If it is matched with the expressions, like evaluation value. So if it is matched with the evaluation value, then this evaluation value, any one evaluation value, if it is matched, so he will go to inside that block. If it doesn't match, he will not go to that block. So let's see, I'm giving 80. So that times he will not match this one. So he will go to the next one. If this one has been matched, so it will go to insert this one. Now I told you that if one time he will go insert, then he can fly to others one without any corrections. Do you understand? Without any condition checking, without any matching, you can go to the next one. So that's why, because all are in the same block as well, in the switch block. So that's why we have to break so that he can execute one statements and then he can go out. Okay, so whenever 80 will true, he will execute the break and then go out. So he should not go to the next one, because if we are not giving break, so that times he can easily go to the next one without checking the condition of the case. Do you understand? So that's why we have to place break in every place, break in every place, break in every place. Okay, break in every place. Now the point is that as we are using break, so now the problem is that, okay, when
Not the last break, sir.
we do not need the last break. Yes, we
Yes,
do
sir.
not need the last break, because default is that after this one it will go down. Okay, it will go to outside, no problem. So that's why there is no break in here. Okay. Now the point is that, is it correct according to our solutions that we want? Is it correct?
Sir, here only taking 90, 80, 70. But is it containing any range, sir?
Yeah, so it is not continuing any range. Yes, you are correct. So if we are running here, so if we are giving like 676, it will go to F, but it should be print to P. So what is the problem here? There is no range. Only we are giving 90, but there is no range. Can we make a range in the switch statement, through the switch statement? Is it possible? How? Tell me. How to make a range?
Sir, n is greater than or equal to
You
90.
cannot use greater
Sir,
equal I.
take another variable
You
and
cannot,
divide the value by the 10
first
and
listen,
store.
first listen. You cannot use 90, 80, 70, 16 here. I mean, in the here, in the greater than or less than, Conditional statements you cannot use here. Do you understand? This is the first thing.
So number equal to number भाग 10.
Yeah. Wait. So you cannot use equal sign also here. Do you understand? So that kind of problems we have. Okay. Now what is the task you are telling?
So number equal to number divided by 10.
The number equal to number divided by 10. Okay.
Yes, sir. Then the result are 10, 9, 8, 7, 6. Those are the conditions.
Those are the conditions, right? Okay. Yeah.
Yes,
So
sir.
so any other things you have? Any other things you understand? I mean, any other observation? Any other thing we can use? Actually, if you think in this way, that we can use first. Yeah, if we are thinking like that, so we have to use, like, if we want 91 should come, so 91 we can do 91 as well, right? 91. If we need 92, we can add 92. In that way, there are a lot of statements we have, but there can be a solution. This can be a solution, right? But a lot of statements. Now, yeah, anyone want to share, right? So another person who is the girl who want to talk. Okay, so now the solution is that what we did is that the number you can do in that kind of ranges. Okay, you can make this kind of ranges, and you,
So first we have to take an variable,
yeah.
new variable.
So now we have to take a new variable which is
Yes, sir.
num, and we
That's
will
the
tell that num equal
number divided by 10.
divided by 10. Fine. So we are taking this one. So we are passing now num. So we'll passing 9. We'll passing 9, 8, 7, 6, and default, right? So what does it means? Why we make is divided by 10. So now you can see that if you read 86, 87, it will print. So if you give the output 87, you give the input 87, it will print UB. So if you give 76, it will print C. So, and if you give like 20, it will give you F. So whatever we want, that we have got this one, right? So this is the solution for your number one problem. So the point is that by default, if you run F1, so you can compare in this way, because the range is fixed. The range is fixed. So that way, basically, we can do, right? Because of the range is fixed. That's why we have divided by 10, and we can collect this data because the range is fixed. Sometimes you may not have range fixed range.
Sir,
Yeah.
sir, if we put 87.2 fractional number, then what will be?
Fractional number we don't, because we have taken integer. We have
Yes.
already mentioned that we will take integer value. We already mentioned that we are
Sir,
taking.
we need one for 10, sir. If
Okay,
anyone
sir.
get
Yeah,
100 out of 100.
you're right. So we need for 10 as well. Yeah. So just placing 10 is also okay. Yeah. So you need like you want to 100. If someone is giving 100, got 100 out of 100, so then it's needing 8. Yeah. The same thing we can do. Yeah. So that's it. But now still, if we this one is the solution for that problems that we find out. So you see, I didn't write down anything. So see here, if I will not write down anything in here, let's say I will not write down anything, what will happen? If 10, still he will come here. So that things also we can do, like case 10, case 100, case 99, colon, and then like 100 statements we can put, right? Anyway, so this is the solutions we have made. Okay, for these solutions, if we run this one, I have taken a starting time for system nano time, and I also take an ending time, and I minus these two, and I find out that how much time the processing has been taken. Right, so when I will run this program, so please write down this one, okay? So when I will run this program, so I find out the processing time. The processing time has been taken. Okay, let's see. I'm giving 30. So the processing time is 58070. 58070 for 30 is the worst case one. For 30, 580,700. This is the worst case one for 30. And for, let's see, for I am taking, let's see, I'm giving the best case 90, or worst case 90, which is taking, why it's taking much more time. Okay, let's see, taking I give 90, so it will take 633,800 nanoseconds. Okay, nanoseconds. That should be the best case, but it's taking like that. Okay, anyway, so let me run again. Let me run again. Let's see, give 90 or 100. Let's see, giving 100. So it will take 185, 900, 400. Okay. Now run again, and I'm going to check for 90 again. 192. Let's see. 893,600, something like that. Okay, so if you go to average time, we have seen that the average time is coming like 600,000, like 600 nanoseconds, 600,000,600 milliseconds. Okay, something like that. Okay, fine. So this is the program we have. Okay, so this one is grade 1.java. Yes. Yes. NanoTime is the method of system plus. You see, System.nanoTime we have used. And those are the long value we have used, the starting time, ending time, and elapsed time. Okay, so that's why basically we can generate the timing for a program. So we are only considering the, we are not considering the IO time, how much time you delay for IO, that we are not considering, because after that, after taking the input, we are starting time, we are calculating starting time, and we are ending time, just the processing time of the switch we have calculated. Okay. So that way, basically the elapsed time of processing the switch statement we have calculated for 300, 30, 90, 100. Okay. Now, the another students implement the same problem with if statement and does mistakes as also. So another students also did implement this one into if statements. How he has done if statements? Let's see, he convert this one to if statements. How he did the if statement? Let's see here. So he's doing this way, that if, okay, let me go for this one. Yeah. Uh, yeah, so let me think in this way. So switch is not required now. Okay, so now he's using like that. So, and you have to mention me that what is the logical errors are here. Logical error, if, let's see, number we are taking number. Okay, let's see, I'm not creating number now, I'm considering numbers. Number if statement. So number is greater than, the same thing we are writing this one, whatever it has been written. So number is greater than equal to 90. We are printing that system.out.println, right? We are doing this one. Okay, again we took, so I'm deleting this ones. Okay, I'm taking this one now. Okay, number is greater than 80. I am printing B. Number is greater than 70. I am printing C. Number is greater than equal 60. I am printing D. and if number is less than, wait, number is less than 60, less than 60, less than 60, he's printing F. Okay, now he has done these things and made a mistake, right? So what is the mistake here?
A need break, sir.
It breaks. Okay, do you think that it needs break will work here?
No, sir, we
Sir,
can
we can else if, sir.
else if,
Else if,
sir.
sir.
Sir, need range.
Sir,
Yeah, need range. That's the main
Logical
thing.
and
We need logical and. Okay, fine.
Sir, we need condition also.
Condition. Okay, fine. So condition we are applying. We need logical. Logical both. We need the range to create. So greater than we have created. Now less than we should have to create because we have to make a range. See, where we are using if clause. If clause we are using, if statement we are using where we need range, right? Where we have range, so that times we are using if statements. Grade, you see switch, we didn't use range here. We use same number comparisons or same thing we have compared. Some similar case, is it umbrella or uh, is it a ball or is it a cat? So which one you are going to choose? So the choosing options you have fixed, and 3 or 4 choosing options. So that times you need to use switch. That times you cannot use. When you have range, we cannot use. If the range is different, we are basically will not choose the switch statement. You understand? That's also learning here. Okay. So where you are going to choose switch, where you are going to choose if else. Every time if else you are choosing, this is not good as well. Okay. Okay. Now this we are doing. Okay. So now we have range, the higher range and lower range. Okay. So now number less than 100. That's you need, right? So that times you have a. So now less than, let's see, we are taking that 100 will not come. 100 will not come. Let's see this one because of writing. My copy should be. Do you understand? My copy should be okay. That's why. Okay. Okay, so that's why I took that. Let's see, 100 will not come. Will not give 100. Okay. So let's see 80. So that's why I took this one. Okay. So let's see. I took 70. Now this one is less than 60. Now what do you think? This program is okay?
sir, so last one is greater than 0.
Less than,
Yes,
greater
sir.
than 0. Okay, so let's see. We have the integer number we are taking. Okay, so greater than 0. Okay, fine. So less than greater than 0. Okay, so greater than 0. Now if you run this program, so what do you think? This program will work, right? Let's, yeah, let's check. Let us check this. Let's see 90. Let's see 90A. So let's see, run file with 30. 30. So it will giving A. Okay, and then let's see, we are using 90, 100. So 100. So it will not give anything, right? So okay. So let's see 10. Let's see 70. See, okay. So this one equal, you can give. Okay, no problem. Now the point is that now we have a program. So which one is file open? File open. We have a program which is grade 2. So this program is given to you. Okay. So now this ones we have developed so far, right? We have developed this one, right? So we are taking the time for this one also. So when we are building this one, and let's run this one, when you are running this one, so we are taking like the 3 inputs that we have taken. Let's see, 30 for 31, how much time? 562400, 562400. And then let's take, we are running with 90. So this one is 221,700. And let's see, we're choosing 100, only 600. So it seems that switch case, so rather than switch case, it seems that if is taking less time than the switch case. All switch case also comparing all, right? And here also we are comparing all. You see, I make the same thing with the switch case. Switch case has 1, 2, 3, 4, 5 comparisons. Here also we have 1, 2, 3, 5, 4, 1, 2, 3, 5, 4, 5. So 5 comparison. Actually 100 we didn't consider 100. So let's see this one. Oh, 100 is not here at all. Okay, 100 is not here. So that's why maybe it takes some time. Okay, let's see 100. That's why there is no printf here. Okay, 101 printf. No printf. Okay, so that's why there is no printf here. Okay, now we can take 100. Yeah, 513 200. 200. So it seems that, so if you do much more than observation, then this one should, this one and switch is taking similar amount of timing. Okay, because switch also we are comparing all 1, 2, 3, 4, 5. We are comparing all. We are matching this one to all switch, and in the case all the cases has been trying to compare. So we are trying to compare with all. Okay, and then go break and then again come and then again break. So if this one is true, then also we are considering this one, we are considering this one, we are considering this one, we are considering this one. So if one will take 5 seconds, five, let's say 5 nanoseconds or 5 comparisons, then how many comparisons? So one will take 2 comparisons. So every time for each statements, for each one, 31, we have to consider all. We are checking for all, right or wrong? Same thing in the grade as well. We are checking all for anyone. But if the first one will come, he will go out, and then if the second one will come, he will go. So two comparison he has done. But here we are comparing every time all comparison will be done. So this should be taken much more time than the previous one. Okay. Now why? See here, if one execution will take, one statement comparison will take 5 nanoseconds. So 1, 2, 3, 4, 5. So 5 statements, if you go for 5, so it will take 5 into 5, which is 25 nanoseconds, as each one is taking 5 nanoseconds. So every time he will do for one statements, one for 30, for 30, number 30 we are giving, we have taken 25 nanoseconds. So for 5 1 he will take 25 into 5, which is 125 nanoseconds. Right or wrong? Understand my point? So one statement is taking, because everyone will need to be compared, everyone, as this one is an if, everyone need to be compared for one number, right? So that's a little bit complex, and it should take much more time than the others. And here also you have to compare that how many conditional operator you have used and how many logical operator you have used. Now can we change this one to make much more faster?
Yes, sir.
Yes, we
If
can.
it's using if it's
So we are trying to do this way. Let's see if I can take else here. Okay, and then bracket. I put everything inside the bracket. So what will happen if this one will be true, then fine, he will do, and then he will not check the rest of them, he will go out. Else he will go to the down one, as like switch case. Now as like switch case 1 is done, so he will do and then break, go out. Else he will go to the next one and then check. So this one is now as like switch case is coming. Okay, fine. Now this one again, if we have, okay, so now in this one also we can place else, we can place else here. Yeah, so there's all the things we can place inside an else again. So if this one will be true, so then we put else here, and if this one will be true, then we are placing else, all the inside, all are inside else, right? So this we did. Yeah, so this one I'm doing this one. So this one is inside this else. Let's see. The same way, so whenever this one is true, then he will go out, else he will come in here. So when this one will true, so he will do else, he will do the rest of them, right? So we can take in this way. And we can place a bracket, right? Now, if this one will true, then also else we can tell, else we can, without comparison, we can place else. Right? So now this is called if else, right? So if else joint, you see, couple if else, not else if else. Here, if this one is true, then he will go out, else if this one is true, else will not be executed. If this one is false, then else will be executed. Again, if this one is true, then this one will be true, else will not be executed. In that way, let's see how much time it will take. So now building this one, we do not have time. Yeah, we have time. So let's see, I'm running this one for 30. So 2 to 4, 4, 200 for 30 only. Okay. So then I'm running again for 100. We have 100, right? Yeah. So 6 to 8, 200. Okay. We are running again for 90. 7 to 9, 600. So it looks bigger, but anyway, if you do 1,000 times this one, then you will feel that this one is much more slower than the previous grade 2 algorithm, right? Because we have used if else, because every time. Now let's see, I have this one. So the first one, like let's see this one, the first one, comparison time will be required for every time is not 5 is not comparing. For the worst case, for this one need to be compared 5, right? For like for less than 60. For 50, this one is not true, he will come here. This one is not true, for this one will come. This one is not true, this one will come. This one will not true, then it will come to here. So that times all the comparison is required. Otherwise, full comparison is not required. So that's why we are taking the middle one in an average. Okay, so this one is the worst case and this one is the best case. One comparison and this one is the 4 or 5 comparison. So we are taking the middle one. How many comparisons? Let's say 3 comparison. So what the every time we need 5 comparison, now we are taking that for anyone we need only 3 comparison. So 3 into 5. So 3 every time for, I mean, for 3 instructions. For the first one we had 5 into 5, right? So now we have only 3 for 1. Only 3 for 1. Okay. So 3 into 5, that's mean 15. For 5 checking, we need 5 evaluation testing, we need 15 nanoseconds. So for 25, we for no previously it was previously for if we had for every one okay, test every test, okay, test number is the 3 we have. For every test we have called 5 1. So every test, so 3 tests will require 3 into 5. So that's been 15. 3 tests will require, every test required 1 2 3 4 5. Okay, so now 5 was required before, so now it is taking 3. Okay, so that's it. 5 into 5 was before, but now for 3 it was required, for 5 it was required 5 into 5 before previously, now it is required 3 into 5. That's mean 15, because on an average we are taking this one as 3. So it takes 3 comparisons. So this is the comparison. If you compare the time, then it will take like 5 into 3 into 5. So if you take time, let's see 5 nanoseconds, so 5 into 3 into 5. Because each comparison will take 5 nanoseconds. So 5 into 3 into 5, that's been 15 into 5, which is 75. But in the previously, it was taking 5 into 5 into 5. So which is
Sir,
75. Yes.
Do we need logical operation here because we are already checking if the number is above 90 or not. If it's below 90, it's already down.
Yeah, the first one is not, first one you don't want to check the 101, right?
Yes, sir. Sir, for all of them, sir. Do
All
you
of them.
need?
Yeah,
Do
so now,
you?
yes,
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 sir.
yes, I don't want to tell this one. This one you have to mention, okay? You
Okay,
have to
sir.
mention in your report, okay? If, then what is the intelligence you have, and Rashid have and Safi has, so that should be different, right? I should not tell you. This one you should have to do, okay?
Okay, sir.
That is there, that is there. You didn't think that the question is not here. See, replace all logical operator. Okay, write your findings and modify your code and selection statement so that it reduce total operator count. You understand my point?
Yes, sir.
Okay. So you need to, operator count should be reduced. Now this one and else if ladder, you have learned else if ladder are same thing basically. You understand? Else if ladder are same thing. Why same thing? See here, if I will place this one and take it in upper, so this one is the else if. Same thing here, because you have one statement, so that's why this one is the else if ladder. So this one, you see, same thing. And this one is also you can take and place in the place of else. So this one is the same thing, right? So so we don't need these brackets anymore. So what is this is else if ladder, so we are placing in here, and this one you will take in here, so this one will be placing, let's see, I'm placing in here, I'm placing in here, so this one I will place in here, so that one may be shifted a little bit. No, it's okay. And then I will shift in here, so else. Yeah, so then I'm shifting this one. Yeah, so now if this one is true, then this will not be executed. If this one is false, this will be executed. The same thing we had. Okay, so now bracket is not there. Bracket is for your understanding, but this one is called else if ladder. So else if you learn that this one is true, then they will not execute. If this one is false, then he will compare this one. If this one is false, he will compare this one. If this one is false, that way basically you can consider. Okay, so that way you can solve the problems as well. So this, now the condition, now the problem is that your task at your home is that replace all the logical AND operator to bitwise operator. Compile and run code. Is there any difference between your solution and bitwise as operator solution or not? Write the findings and explain what is happening. So modify your code and selection statement so that it reduces the operator count as well. So I want you to be modify this one and make much more optimized code by reducing the operators. Okay, so you can reduce the operator. And one thing I have mentioned here, that can we replace the logical operator to the bitwise operator? We have two bitwise operator. One is called, we have three bitwise operator. One is called and or not. Not is okay, not we are using the same way, but and or. Okay, so those are bitwise operator we can use as logically in here. So how this use? So what is the difference between this one and this one? Okay, so and also this one and this one and this one. So this has difference. What is the difference? Let's see, we have a and b, two variable. Okay, a and b, two variable. A is 5, b is, let's see, 2. What will happen? The first one, logical operator. When we check logical operator, if a and b, and for bitwise operator, what will happen if a and b, they have the difference between these two. We have difference. Okay, so what is the difference here? What he will do, a is 5, that's mean 101 in the binary, and here also b is 2, so 010. So he will do the operations on bitwise first. you will do the operation on the bitwise first. So the bitwise operations will be, so bit by bit, so 1 and 0 will be, and is there, so 0, result is 0. So this value came as a 0. So when you check the if statement will not be executed, you have to go to the else statement will be executed here. You understand the point? So it's very important. But here a equal 5, b equal 5. What is a? A is 5. That means this one is true. Except 0, anything is true. So b is 2. That means this one is also true. So true and true is basically true. So this one will represent true, and so he will go to if, he will not go to else statement. You understand? That's the difference between these two have. So bitwise operator will do bitwise operation first, then he will consider the logically the operations he will improve. But here logically left side and right side he will consider first, and then he will do that. The same thing for or as well, but or will be result same. If and else will be result same in that case, like or and or. True, true is true for OR case. And here OR case will be 1, 1, 1. So this one will also be true. You understand? So that way basically bitwise and logical operator will impact in your program for conditional situations, right? So for logically taking decision. So so that's for we have so far we had for our bitwise operator. Okay, so for our selection operator, now we are going to this problem you can check this one, the same thing that we had taken previously as like grade comparison we have done, right? So like grade 1 program, okay, we have grade comparisons we did. So where we have like grade 1 programs, right? We compare 9 number is greater than equal 90 or not, number is greater than 60 or not. So we make a range and then compare the range. Here the range has given, right? But I told you that the range is not equal. So what you're going to do? Range is not equal. See here 16 to 18, here 18 to 24, here 24 to 29, here 29 to 35. So and above 35. So range is not equal. So how can you solve this one? Do you understand? So how can you make minimize? So 16, 17, 18, 18, 19, 20, 21, 22, 23, 24, 25, like that? Or how do you solve this one? Any range can you find out? So that's is your work. So you have to use switch statements and later if else, convert this one to if else. First you have to use switch statement and later optimum if else you have to find out, right? So BMI value will be taken to consider you if you give the input to height, and also if you give the weight input. So height and weight you will calculate height divided by weight, I think so, kg divided by weight, meter square. Okay, so height square. So if you divided the weight by height square, then you will find out the body mass index, BMI. So then you will calculate this one. So BMI will be calculated. Then you can compare the BMI. That what is the compare. So you have to use switch statement as well as you have to use if else statement. Please do that at your home. We already solved the problem, so you can do that, right? You need to copy from others for doing this problem?
No, sir.
So if you copy, then what should I tell you? বলেন আমাদের কি করা উচিত তাহলে? What should I need to do with you? You understand my point? Okay. Now I'm coming to a good programming problem which is called Monte Carlo. Okay. Now I'm in task 4. So Monte Carlo simulation. Okay. So Monte Carlo simulation is a very important, very important problem. Basically, we use Monte Carlo to find out the random value, some random value we used to find out by using Monte Carlo method. Okay, so we find out some random value. Okay, so you know pi pi is 3, pi value is 3.14. 3.14. Then we have several diseases. Okay, let's see. If you search in the Google, so what is the pi What is pi latest value? See here. Okay, so 3, that's basically it will be 3.14, then 15926 535,893. In the way, the last precision value for pi. What is the last precision value of pi? Don't want to remember those. You also don't need to remember those, just to search. Okay, so just to search to see that what is the last value of pi. So 50 decimal places. You see pi value to 50 decimal places. Okay. Oh, why is this one? 50 decimal places, they said. Well, after 50 decimal places, value of pi after 50 decimal places, they can find out. Okay, okay. So, no, the accurate one, they have made, yeah, like that. This one, like that. Okay. So, so So that kind of like 23 or 24 is the actual value someone has been find out. Okay, some professors from Tokyo Institute of Technology, my university, my PhD university. So they find out this one, that the last digit of the pi, and I meet with this professor. Okay, so I had his card. Still, I had his card um, in my card folder. Okay, so we meet together at night, one night, and we talk like 5 to 6 minutes, and then he told me that he has the pi. Okay, he has the pi values, those at that times. Okay, so nothing more special. We didn't have any talk. So like that, this is the last value. So last value of pi, how many digits they have, something like that. I don't know, I forgot his name as well. Okay, I forgot the last digit of the pi. They have find out that time. Okay, that time. So I don't know now. It's being like 2020, around 2009, so 910, so around 11 years. So I hope that many improvement has been done. Okay, anyway, so that times he was the last. They find out, their lab find out the last digit of pi. Anyway, so now the point is that we are considering to find out the pi values. Okay, like pi values. What is the pi value? One of the method, we can use Monte Carlo method. What is Monte Carlo method? Let's go for that one. Okay, Monte Carlo method. So in the Monte Carlo method, we have, let's say I'm taking a circle, and I want to take a square around the circle, the smallest square around the circle, around the circle. Yeah, so this one maybe a little bit gap is in here, but think that there is no gap. Okay, so think that there is no gap. Okay, please consider this one. So if we have like that, so the times we have like that. Okay, let's think that there is no gap in here. Okay, so now if you think that there is no gap, so the times what will have is that, what will happen is that we have, if the radius is r, so this one is r, this one is r, this one is r, this one is r, right? So if you consider this one, have you played dart game? Western movie গুলোতে দেখা যায় না, dart throw করে মারতেছে, তাই কি না? Have you seen this dart game? দেখেননি? I hope you have seen. মনে হচ্ছে যেন কত ইম্পর্টেন্ট, মানে কত
Yes, sir. Yes, sir.
কত কঠিন কিছু পড়াচ্ছি যে আপনাদের অ্যান্সার দিতে ভয় লাগতেছে। ডার্ট গেম, রাইট? You have played dart
Yes,
game.
sir.
So the dart game. So sometimes it happens that within the circle you can put this one, or sometimes your dart will go outside the circle. happen, right? If you throw, sometimes it can go to outside the circle as well. So now the point is that we are thinking that if it is go outside, then it will be inside the square. It will not go outside the square. You understand my point? It will not go outside the square. It will always be inside the square. That's what we are thinking. Okay. Whenever you dart will throw, it will be always inside the square. But sometimes it can be inside the circle. Sometimes it may be outside the circle. Do you understand the point? Sometimes it may be inside the circle. Sometimes it may be outside the circle. But it must be inside the square. Okay. So now the point is that what we're telling is that uh, okay, so if this one is inside the circle, okay, so it always inside the circle. That's we are thinking that we will do something so that it will always be inside the square. You have to understand this one. Okay, now this is the circle. Now if you throw the dart, if the circle and the radius is becoming bigger, if the circle radius is becoming bigger, then the square will becoming bigger. Then if you throw the dart, so there will be much more possibility that the dart will be inside the circle, right? Yes or no? If you make the circle closer, then there is a much more opportunities, less opportunities that the circle will be inside the dart will be inside the circle. So what we are telling is that you're throwing number of throw. So you are throwing that number of darts, okay, number of points, let's see points, number of points placed at circle, যতগুলো পয়েন্ট সার্কেলে পড়বে divided by ratio, okay, number of points inside the square will be equal to their area as well, their area ratio as well. So because if this one will increase, this one will also increase. The possibility of the heat will increase in here. So the number of heat will increase. So the ratio of the area will cover so the same thing will happen for here as well. That number of they are same. Number of area, not area of the circle, divided by area of the square. Area of the square. They will be same. The ratio is same. Okay, ratio will be we can say সমানুপাতিক, but সমানুপাতিক we can say, but rather than we can say সমানুপাতিক, we are saying that they are same. Okay, think in this way, we are same. We are not using any fractional any factors in here. We are not using any factors. So we are telling that no, same, nearly same, so same. That's we are telling same. So the ratio of the square and circle and the heat in the circle and the heat in the squares will be, the ratio will be same. Okay. Now, this is a theory. Let's see, this is a theory. So if this one is a theory, this one is correct. So that times, and this theory is correct. Okay, because I told you that if area is bigger, then much more dart will be inside the area, inside the circle you can draw. So the ratio will be depending on the area as well. Okay. Now the point is that if you go for this one, then we can find out the area simply if we know the R. Let's say R is 1. So R is 1. So this is my center, so 0. So if I'm thinking about this circle, this part of the circle, let's see thinking about this part of the circle. So this is the square. Okay. So the area of the square is of this one will be 1 into 1 R square, right? So R square, let's say R square, and area of this circle will be 1/4 of this circle. So 1/4 pi R square, right? So now, so the spin that, which is means that 1/4 pi R square divided by R square. R square will be exit cross. So pi value will be, so we are coming pi in here. So pi value will be, so pi equal to the 4 into number of points, if you throw the dot, number of points inside the circle divided by number of point inside the square into multiply 4, you will get the value of pi. Okay, the more you will do, the random point more you will create, so the more accuracy you will gain. You understand the point? Now, how do you make the point? Randomly, how do you generate the point? So that's Monte Carlo. Randomly, we are generating the point from 0 to x-axis is from 0 to 1. So this one is x-axis, and y-axis is also from 0 to 1. So we are pointing point inside the circle or not. So if x value is less than equal to 0 to 1, okay? So if less than equal to, I mean, if x is greater than equal to 0 and less than equal to 1, then this one is in the circle, and y is 0 to less than equal to x and less than equal to 1, so this one is in circle. So let's see, you have created the point 1000 times. 1000 times the point will be in the circle. Randomly you create the x and y, and these values are, let's see, 800 times. So inside the circle, so 800 divided by 1000, total you have total created 1000, and 1000 of them x y is within the circle radius, within you can create the distance as well. Okay, I forgot. So x y you have taken from 0 to 1. That's mean every times the 1000 times x y will be from 0 to 1, and then you x and y point from the center, you can take the distance of the xy point. So distance from 0 0 to xy, you can find out the distance, right? X square, x minus 0 whole square plus y minus 0 whole square. If this one square root of, right, is this one is less than equal radius r square, right? So then I'm taking r square, so that's why the square root has gone, right? So square root of x minus 0 whole square plus y minus 0 whole square is basically the distance, right? So distance is less than equal r square. R square is 1. I have taken 1 because 0 to 1, 1 to 0 is 1. So less than equal 1. So then we are telling that this one is inside the circle. If it is greater than 1, that's mean here, 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 here. So those are not in the circle. So let's see, 1000 we have taken. So 0 to 1 we have created the point, and 8000 is inside the circle, which is less than this distance has been covered, less than this distance, and the 200 times those are in the outside the circle. So that's mean that the point dart in the point in the circle is 800, and number of point in the square is 1000. Multiply with 4, then we'll get the pi value. Okay, we'll get the pi value. Now, why this algorithm is very much popular to calculate? There are a lot of algorithms for calculating pi. So this one is much more popular to calculate the pi value. Why? Because you see, because um, you see that, let's see, I'm telling Saifuddin, or Saif, let's see, Saif, can you throw dart or create point in your computers that can generate this kind of value for me? Saifuddin tell that, okay sir, 10,000 times I can do. So in his computer, he find out that within 10,000, let's see, 9,000 is inside the cycle and rest of them are not inside the circle. Okay, so you find out this one. Now I told Rashid, can you do that? The same thing. Rashid tell that, okay sir, I will also do 10,000, and he find out that 8,000 is in the circle and rest of them are not in the circle. So 8,000 times he hit inside the circle. Okay. Now Ibrahim, I told him Ibrahim. So Ibrahim also told that, okay sir, 10,000s, and I am getting 9,200. So now what will happen? You see, I have the total 30,000 dart hit result I have. So 30,000 I have, and I have how many hits? 9,000 into 9,000, 18,000 plus 18,000, 18,000 plus 8,000. So that's mean that 26,200, 26,200 times I have hit. So that way, basically distributed, we can generate how much hit we have. And then at the later, they will send me all together. I can multiply with 4. This ratio I can find out and multiply with this 4, and then I will generate the pi value. You understand? So this one is not an overload for your case. If you generate the 30,000 times, you may not get the 26,200. You may get 25,000 times, but it doesn't matter. If others wants, we can include more and more and more and more and people, and one person should not do this one. Parallelly, we can do, and we have less time. So let's see, 2 days. So 2 days we can finish this one. So I have 2 days. I can do 10,000 operations. You can do 10,000. You can do 10,000. You can do 10,000. In that way, basically, we can distribute it and we can merge them together because this is totally randomized. So we can cumulatively we can give the solution. So pi value we can provide in this way. You understand? So that's why this one is much more effective solutions for pi. As much as possible randomized solutions you can provide, as much as number of throw and as much as number of hit, the more accuracy we can find out. You understand? More accuracy we can find out. So that's why the number of hitting squares or number of time you are generating the numbers, so that's should be increased, random increase. So many increasement, you are going to nearby to the pi calculations. Okay, more accurate pi calculations. That's we are going to do in a distributed way. So I have solved the algorithm. So what I ask you to just a few questions that you understand this problem or not. So please answer those questions. This is very simple one, very simple one. Answer those questions and answer those questions. Okay, well, so that you can understand the problem and understand the loop as well. Okay, that's very important. That's we have used the for loop, and number of trial we do like this amount of try we use. So number of try divided by number of hit, which is basically the distance we have measured, that x square plus y square is less than equal to 1 or not. 1 is the radius. So r square, 1 square, and 1 is the same. So that's we have counted. So 4 into number of hit divided by number of trial is this is our basically the program. So program is very simple one. So that's why we can find out the pi value. Now how much time we have? 4:47. Okay. Can I have 3 minutes break?
Yes, sir.
Yeah, I'm taking 3 minutes break because I don't want 2 hours to sitting in the same place. Do you understand?
Yes, sir.
Walk a little bit.
Yes,
Okay,
sir.
and then I will come back. So now we have another important problems that so we have very important for loop and selections we used, which one is basically called greatest common divisor. Okay, so which is basically called GCD or greatest common divisor. Now the point is that how to find out the greatest common divisor. Simple thing, right? The name is representing. What is the name? Are you there all? Are you are you there?
Yes, sir. We are.
Yes, sir.
Yes, sir.
Okay, fine.
Yes, sir.
So now we are coming to task 5, which is that give two number not prime. Okay, not prime one to another one. So we are not considering any prime number. So greatest common divisor should not be 1. That's for sure because it is not prime number. Okay, so and find there be any one numbers not prime to one another. So one can be prime, but not both cannot be prime. Okay. So find out the greatest common measures for them. So two number you are taking. So you see, I have 16 and I am taking 24. Two number I have taken. Now you need to find out the greatest common divisors. The name itself solving the problem. Greatest common divisor. That's mean what? The largest divisor, common divisor. Both will be divided. So that number you have to find out which one is the largest common divisor, right? So largest common divisor, let's see, we have 2. We are taking 2, starting from 2, okay? So 2, can we divide 16 by 2? Yes, so 2 is the divisor in 16. And also, can we divide 24? Yes, so 2 is a common divisor, so 2 is a possible of GCD, but this is not the common greatest one. This one is GCD, but not the greatest one. We have to find out the greatest one, greatest common. This one is common divisor, but not GCD, okay? Now, we tried with 3, is not divisible. Any one is not divisible, that means this will not be a greatest common divisor. This will not be a candidate for the greatest common divisor. We'll go for 4. Yes, 4 is also divisible. 16 is divisible by 4. 24 is divisible by 4 as well. So 4 can be a CD common divisor. So 4 can be a greatest common divisor, but we are not sure yet. Now we are going for 5, not 6,
8 will be greatest maybe.
not, then 7, not, then 8. I'm showing you the algorithm, okay? I know you know the sequence, but I'm showing you the sequence how we are going. So 8, we are using a for loop, okay? So we are using a for loop from 2 to 8 we went. So 8, so 8 is 16 is 2 and is divisor. So 8 we come to as a GCD, but not yet. We cannot decide that 8 is still the greatest common divisor. We are trying to 9, 10, 11, 12, 13, 14, 15, then comes 16. 16 divided by 16 is 16, but it is not divisible. So 16. Can we go for 17? No need, because 16 is the lowest. 16 is the minimum numbers is the 16. So 17 cannot divide 16. You understand the point? So we don't need to consider 17. We have to consider the minimum one of them. So 2 to minimum one of them. So 2 to 16. Any one is greater than the divisor. So that times we have to stop the loop. So loop starting point is from 2 and ending point is when anyone is greater than from k is greater than from the any one number. So it will be turned off. So that is our condition. We have the starting point. When you are using loop, so you have to think about the starting point and the ending point. What is the ending point of it? And in the meantime, who is the greatest common divisor? We can find out in CD, because whenever the common divisor we find out, we updated this one. So 8 is the greatest common divisor. So we can print GCD is 8. So that is called exhaustive search, exhaustive calculation, because raw calculations we did. How many times the loop has been executed from 2 to 17? That's mean 15 times at least. 16 times he has been used. 16 times the loop has been used. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 times the loop has been executed. If one time the loop will take 2 nanoseconds or 3 nanoseconds, it will take around 39 or 40 nanoseconds time. So 39 nanoseconds, so 40 nanoseconds time. Now, this is our first program that's we are talking about. So we can go to this one and we can run this one. We can run this one. You can see here greatest common divisors. I have a program, so I'm taking this program. So where I have greatest common divisor.java. So I'm taking this one. So this one is our first program. And then when we run this one, you see, no, I have changed here. I have made changes here. Yeah, I have made changes here. So let's go to our website and see the website, the greatest common divisor number 1. Yeah, see here, k equal to 2, and for k is less than n1 and k is less than n2, k is the common divisor, possible GCD, which we are taking that k, the loop will execute. If anyone k is greater than anyone, then the loop will be turned off. So we are using while loop. So if n1 modulus k equal to 0 and n2 modulus k, then we'll update GCD and k plus plus. That's the program we are doing. So that program basically I have, yeah, so copy. So I have my program is in here. So that's one is my second program basically. So I'm writing this one. So now I'm going to run this program, build and run. So you will see that if I will do 16, 16 is my first number and 24 is my second number, then the elapsed time is 2600. Now I'm going to work with another one, which is called, can I reduce this one? Can I reduce the timing of this one? Can I make n1 divided by 2, n2 divided by 2? Can it possible? Can we make n1 divided by 2, n2 divided by 2? Will it work? No.
No, sir, it will not work. It will
It
give
will,
us error because of logical
no,
error, sir.
not logical error. Let's see 5 and 3. Let's see 5 and 15. What will happen in this case? You have to check till the end of the number, because 5 can be the divisor. The smallest number can be the divisor of the greatest, the another number. So that's why you have to check at the end. Do you understand my point? Like you can start 2, 3, 4, 5, not less than 5. You have to consider 5 as well. So 5 divided by 1 and 5 divided by 3. So 5 is the common divisor. So you have to consider 5 till 5, the minimum one till. Now this is the way, so we cannot reduce the loop. But Euclidean, okay, Euclidean algorithm is one of the greatest common divisor algorithm, which has been used, one of the greatest common divisor algorithm that has been established by Euler. So this one is called Eulerium. What is this called? This one is called Euclid algorithm, Euclid GCD algorithm. Okay, how Euclid GCD algorithm works? See here, if you have 16 and 24 that you have learned in your school mathematics. So if you have 16 and 24, if you divided, how do you calculate the GCD? You can divide the 16. The minimum one is the divisor and the maximum one is the dividend, right? So 16 is the divisor and 24 is the dividend. So you are dividing this one, then 1, so 16, you have 8, and then 8 divided by 16, you have 216. So this means you have only 2 times, only the loop will be executed twice, and you can find out the GCD of this number, right? So what is the GCD of this one? So that is the algorithm. That is the power of Euclidean algorithm. It's reduced the possible. It's reduced the possible loop. You understand? So you can see there. You can see I have implemented this one in here. So let me take the 3-1 and I'm copying this one. But here I need to check comparisons of which one is less than, that I need to compare. Otherwise, because I need to, less than is the divisors and greater than is the dividend, that I have to do. So N1 and N2, I have to check them, okay? So that's Control V, and now I'm running this one. Oh, greatest common divisor 3. Okay, so this one is my 3, right? Yeah, this one is my 3. So I'm running this one. Yeah, so 16 and 24, only 500. where I have taken 2400 nanoseconds. This is now only 500 nanoseconds. How much difference between these two? Because the loop, how many loop was required? 16 loop before the previous one, exhaustive one. But this one required only 3 loops. So that way, basically, the program has been improved dramatically, drastically. Okay, and it shows the result. It shows the performance within a simple time domain. You understand? So, so, so that's why I'm telling that here. You see that if n2 is less than n1, we have to check in this one, else this one. Okay, so what we are doing is that if let's see, we have n1, n1 is less than, n1 is greater than n2, what will happen? N1 is greater than n2, so bhajak will be n2 dividing n1, and then we have n2 and we have the bakshesh, right? So bakshesh, we are taking this one. So if modulus, these two modulus, then we are telling that n2 is the GCD, because this is the highest common one we can find out. If not, then we have p equal to n1, p equal to n1. Okay, so p will be n1. So n1 we are taking to p. So p is into, because we are temporarily using a variable, we just swap this value. So this one is let's see, this is our divisors, the value we have after modulus, we have the value. So it will become the n2 now. This will become n2, and n2 will become n1, and then we'll continue again, right? So in that way, basically, the loop will be executed. Whenever the modulus will be done, that times we know that GCD, if this one is a match, then we find out the GCD. So n2 is the GCD, fine. We'll print that. This way, basically, we can do. So either this one or this one, because depending on the size of that. So drastically and dramatically, this one improve the performance. Do you understand? Now, now, now also you can check in the different options. Like, can you improve this performance again by using interpolation search? Interpolation search, you know, binary search. Have you known about binary search? I'm giving you a problem domain. Can we make much better than Euclidean? I'm not sure, but can we make? Because Euclidean is using bakshesh, we use log. So can it possible or not? Which is interpolation search. Interpolation search. You know, interpolation searching, like, you know, binary search. Binary search will find out the middle one, and if you have you have number is greater than, so he will go for searching for this one. If less than, so he will search for this one, right? So this one is so this one or this one, depending on, he will cut down any one side. So this one is called binary search, right? So you are going to search in the middles and then left and right. So the binary tree you can formulate. Interpolation search is using similar kind of binary search, but it is much more efficient than binary search. Binary search has log to n average sketch algorithms complexity, whereas interpolation search has log to n. So we can search. I'm not sure that we can search by interpolation or not, but if we can use interpolation search, so somehow in this program. So can we use interpolation search in this program for finding out GCD of a common divisor, right? So can we do this one? So if we can go to interpolation search in the middle, and then we left the, if this one is if somehow this one is the common one, so we can left this part and we can go for other one. এরকম কোনো decision নেওয়া যায় কিনা, বোঝা গেছে কথাটা? So that way we can think or not. Okay. So that's one of the strategies, one of the way we can we do research. So like I have given you one research topic, so you can think and we can try. Interpolation search. Interpolation search. So that's the importance we have. Okay, so that's it for today's class. I believe that you understand about selection, how selections, which are the selection mechanisms, is for which purpose we can use if and switch. So you understand that where we can use switch and where we can use if else. And you can also you can understand in the loop as well, like for loop and while loop, how we can use for loop and how we can use while loop. So several applications we have seen, and I have given you the report, so you can go through and run those applications, run those code, and see the applications, how this application will how the application has been solved and how the application has been targeted. So that's the main issue, is that to understand the inherent features, like you find out the number of comparisons, right? So in that way, try to find out the optimized solution for the problems. So that's I want to provide you today's class. I believe that you enjoyed the class. Yes or no? Did you enjoy?
Yes,
Or
sir.
Yes, sir.
Yes,
or
sir.
Sir, yes, sir.
are you seriously? Are you enjoyed?
Yes,
Yes,
sir.
sir.
We are
Yes, sir.
learning many new things, and you are elaborating very easily, so it's very enjoyable. We are feeling interesting about programming, sir.
Okay, fine, good. So please go ahead and do it by yourself. Don't copy from others, please. আমি এত কষ্ট করে বুঝাই দিলাম, তারপরে যদি আপনি ঠিকমতো যদি না করেন নিজে, তাহলে বুঝারে কোনো বৃথাটা হয়ে গেল। বুঝে গেছে কথাটা? তখন আমার কিন্তু খুব রাগ হয়।